G'day. In this video we're going to have a quick look at some of the things we can do with MATLAB. This is going to be the first video of two. In this one we're going to look at how we can use MATLAB to do some simple stuff involving vectors and matrices. And then in the second video we're going to show you how we can use MATLAB to generate some plots of some simple functions that might be useful for you. Okay, so to start MATLAB, either look for this icon, you can see it at the bottom of my screen there, or type MATLAB into your search. And when you open it up, you'll be presented with something that looks pretty much like this. So the main area that you're going to be concerned with is, at least initially, is this command window here. This big box in the middle. And it's got a cursor and it's sitting there blinking at you, asking you to enter commands. At its most basic level, we can sort of treat MATLAB as a scientific calculator. So I could put in, for example, 3 plus 4, and it would tell me the answer is 7. I could ask for sine of pi, I don't know, pi over 2, and it will tell me that the answer is 1. Now we're going to talk about particularly how we can use MATLAB for dealing with vectors. So to enter a column vector into MATLAB, we first surround it with square brackets, and then we enter the numbers that we want, separated by semicolons. So you can see I've put 3, semicolon 4, semicolon 5, hit enter, and I can see my output on the screen there is that vector 3, 4, 5. Now the semicolons basically tell MATLAB to start a new row, so it thinks this is like a matrix with 3 rows and 1 column. I could also type in 3, 4, and 5, and that would give me a row vector, should I need a row vector for something. Now I can give my vectors names, so I could call my first vector A, so let's just call it A, so I can reuse it later. And I'll define another vector B to be -1, 0, and 2, for example. Now I've got these A and B set up like this, I can, I don't know, add them together. What else would we like to do with vectors? We could take a linear combination, 3 times A minus 0.7 times B. And MATLAB will calculate it for us. We could take their dot product, so dot of A and B. It will tell me it's 7. Or I could even take, because they have 3 elements, I could take their cross product, cross of A and B. So it's pretty easy to work with vectors in MATLAB, and it's especially useful in a learning linear algebra context because we can use it to check answers to problems that we've been working on. Now, it's great having this command window, but after a while we start to accumulate a whole lot of commands, and often they're ones that we want to run again. So first thing we can do is we can go to where we're up to, and we can hit the up arrow, and then we can scroll up and down through our list of previous commands. If we want to re-enter one without having to type it again, I can just choose it from my list and select it. But let's say we want to save these for another day. Well, if you go to the top left of the MATLAB setup window here, there's a button in my version of MATLAB called New Script. It might be called New M File if you're using an older version of MATLAB, but it does exactly the same thing. So I'm going to click on that, and it opens up this new thing called the editor. And so it's got this text file open. It's a bit like Notepad on a computer. I can type text into it, but it's customized to work properly with MATLAB commands. Also, if we can't see it, we can go to Home and View, or Layout, and I'm going to also get my command history. You notice here it's a useful little list of our previous commands, so I'm going to copy and paste some of these and put them into my M file. So all this file is just a set of MATLAB commands, one after the other, that I can save in a text file, and when I'm ready, if I go back to Home, back to Editor, if I click Run, MATLAB will save my file. I haven't saved it yet, so I'll give it a name. Let's call it Vectors. If I hit Run, it will run my file, and anything without a semicolon on the end will be displayed to the command window. So you can see after I hit Run, I've got my A, my B, and also the output from this A plus B command. If I don't want to see all of my setup, I can put some semicolons on the end, and then when I run it, all I'll see is just anything that doesn't have a semicolon. Alright, so that's how we work with vectors. Entering matrices and working with those is almost identically as easy. So let's say I'm going to go straight into my file now, and I want to enter a matrix that has 3 rows and 4 columns. So let's just make 1, 2, 3, 4 on the first row, 5, 6, 7, 8 on the second, and 0, semicolon to end the row, 0, 1, -1, and 2 on the bottom row. So you can see I've separated my entries on each row by commas, and then I've separated each row by a semicolon. So if I were to now run this file, I get this nice matrix A here, and it's got everything I want in it. I'm going to set up a second matrix B, and this one I'm going to make 3 by 3. So it's going to be 1, 0, -1, just make some numbers up, 1, 1, 1. And on the bottom I'll have 2, -9, and 1 million. Okay, so if I run that, that's great. I now have my matrix A and my matrix B. So just like with vectors, we can do the commands that we want by just essentially typing in the math that we want to perform. So A and B, well, A is 3 by 4, B is 3 by 3, so I should be able to do the product B times A. I'm going to run that file, just run it, and you can see it's calculated the matrix B times A for me. A times B, well, if we just think about that for a second, in fact you might even want to pause and think about that for a second. Should that be defined? No, it shouldn't, because A has 4 columns and B has 3 rows. So those matrices are not compatible. If I ask MATLAB to perform this calculation for me, I'll run that again, I get an error, and this is exactly what I should expect to see, and it even helpfully tells me what the matter is. It says there's an error using times, the inner matrix dimensions must agree. So as you've learned in class, A times B, you can't calculate that if the number of columns of the first matrix doesn't equal the number of rows of the second. Likewise, if I try and add A and B together, I'm going to have the same kind of problem. A plus B cannot be added. Now one thing you might want to do for a matrix is to compute the reduced row echelon form of it. And MATLAB has a command that does exactly that. So I've got my matrix entered here. If I type in RREF of A, then it will automatically calculate the reduced row echelon form for me. So I'm going to run that. And here's my output. You can see it's reduced A to reduced row echelon form, just like that for me. And I can read off anything that I particularly want to read off about this matrix. For example, if A was representing the augmented matrix of a 3 by 3 system of equations, then I could read off my solution here, x equals -1.67, y equals 2.3, etc., etc. Alright, one last comment regarding vectors. Let's say I've got my vector A and my vector B. Notice that everything I typed in my file, once I've run it, it's now available from my command window as well. So if I want to go back and mess around in the command window, I'm more than welcome to do that. Let's say for some reason I actually want to multiply these vectors together element by element. If I type in A times B, MATLAB thinks I'm trying to multiply these two things together like matrices. And so it's going to give us that same error that we had before, that the inner matrix dimensions must agree. Now let's say there's some reason I actually just want to multiply the corresponding elements together. Let's say maybe I'm computing a dot product and I want to do it step by step and multiply the elements together first and then add them up at the end. If I want to do that, I am allowed, but I have to put a dot before my times. And that lets me multiply these two vectors together, element by element. And now you can see I get the vector -3, 0, 10, which makes sense because -1 times 3 is -3, 0 times 4 is 0, and 2 times 5 is 10. Likewise, I can square elements or cube them this way as well. So if I want to take a power of everything in my vector A, remember A was 3, 4, 5. If I want to square everything, I can't do this. This is what you might want to do. That would be squaring using matrix multiplication. So a matrix has to be square to be able to be squared like this. So again, I can square the individual elements by putting the dot before my power symbol, and it will square each element individually. I could cube them, etc., etc. I could do whatever I like. Just have to remember to put that little dot in if that's what I want to do. Okay, I think that's enough for this video, so you tune into the next one to see how we can use MATLAB to produce some plots.